So today we are going to discuss about NAT. NAT on ASA. So first come first, what do you mean by NAT? N-A-T. NAT means network address translation. So it is network means my packet is moving. My packet is moving from one location to another. One location to another. Address. I'm going to convert the address means layer 3 IP. And translate means conversion. So when my layer 3 IP is going from one location to another location, I am going to convert that IP address. So this is network address translation. So basically, if we are going to talk about ASA, it's really vast. The netting is really vast and there are major changes in ASA. So let me divide it into three parts. 1, 2 and 3. So when ASA was introduced, it is running in 7.0, 7.1, 7.2, 7.3, and we will discuss about 8.0, 8.1, 8.2 and 8.3, 8.4, 8.5, 8.6, 9.1 and 9.2 that is currently running. So these are the iOS versions, and why I am dividing this iOS version. This means I'm saying there must be always a difference between this. If you want to perform on 7.0 as compared to 8.0, there is a difference. And if you are performing 8.2 as compared to 8.6, there is always a difference. So there is a command nat-control that is compulsory when if you are running 7.0, 7.1, 7.2 and 7.3. This is operating system version. So it is compulsory. We will discuss what is the use of net control command. Here is optional. So net control optional, and here they removed it. So in this version they removed this command. So you don't need to perform any net control command. It's not supported by it. Here we are going to use the concept of object group. Here we are going to use same net and global. Here also net and global. These are the NAT process, and this is syntax, and this is the iOS version. So first come first, what is NAT control? We know that it's compulsory here to perform the NAT. Here it is optional and here it is removed. But what do you mean by NAT control? What is NAT control? That's really good question. So NAT control, according to the definition, if if you run this command, if you run this command, then if your traffic is moving from one interface to another interface, it should be netted. It should be netted. This command is saying that if you run this command, so you type this command nat-control, you are going to type it in config t, configuration mode, nat-control. So if you run this command, then if your traffic is moving from one interface to another, it should be netted. So what do you mean by moving from one interface to another? So let me tell you how. So suppose this is R1. So I'm going to take, like, it is my assumption that you know the basic behavior of ASA about higher and lower. If you don't know about it, please check my previous videos. So this is in, this is out. So in means higher security level, out means lower security level. So I'm giving a 0. So when your traffic is moving from, suppose this is gigabit 1 0. So when R1 initiate a traffic for R2, if R1 is initiating a traffic for R2, like 12.1, 12.2, 23.1 and 23.2. So if I put a command telnet 23.2 on R1, this is the command that I'm typing on R1. I'm running this command, so my traffic will go through R1, then ASA, then R2. It's clear, right? My traffic will go through like this. So when my traffic is moving from gigabit 0 by 0 to gigabit 0 by 1, and if my net control command is running, already running, so then if your traffic is moving from one interface to another interface, it should be netted. So if I'm not performing any net and if my traffic is going through G0 by 0 to 0 by 1, the traffic will be dropped. So it should be netted. So we need to perform the net. If net is not there and my traffic is going through one interface to another interface, it will be dropped. And if netting is there, it will allow. So this is the command that is compulsory to perform the net. Net control is compulsory. If you want to perform any type of net, you need to run this command. But in 8.0, 8.1, 8.2 and 8.3, this is optional. You can either run this command or not. Without this also you can perform the net. And in 8.4, this command is removed. It is no longer supported. So today we are going to discuss about, first is static net. Static, as the name says, the entry will remain in the net table. Static net is 1 to 1 IP. I will convert a single IP into one IP. So just like I can convert the 12.1.1 IP into something a random IP. This is static net. I am converting one IP into another IP. So let's take an example. Let's create a topology. Suppose this is our firewall. This is a router. This is another router, and they are connected. So this is G0 by 0, G0 by 1, fast Ethernet 0 slash 0, fast Ethernet 0 slash 0, R1, R2, and this is ESP. The IP address is 12.1.1.1 to 23.1.1.1 and 23.1.1.2. This is 100 security level, this is 0. So the first one is static NAT. As we already discussed, 1 to 1. So static NAT means I'm going to convert this 12.1.1.1 IP into let's take 101.1.1. So my syntax is uh, static in to out my global IP 101.1.1.1 and my local IP is 12.1.1. So I'm saying static. This means it will remain in NAT table. It will remain in the NAT table in to out. This means when my traffic is going from this is in and this is out. So when my traffic is going from into out, not from R1 to ASA. So it's going to only perform the net when my traffic is going from R1 through ASA, R1 through ASA to R2. So it's going to only perform when in to out. It's not going to perform any net when the traffic is from R1 to ASA, because I clearly mentioned here that if your traffic is going from in to out, so your global IP is this, your local IP is this. So this is global, this is local. So let's try it on the ASA. So first we are going to demonstrate about NAT control, so what we have already learned. So we are going to go one by one. That we learned in the ASA that if NAT control is enabled, my traffic should be NATed if it wants to go from one interface to another. So this is my same topology. 12.1.1, 12.1.2. The security level is here is 100 and the security level here is 0 and the name is inside and here the name is outside. So I can easily telnet R2. We have basic connectivity. Username Cisco, password Cisco. Cisco. Yes, I got it. So we have the basic connectivity now. I can easily access. So currently I am running the ASA show version. My ASA version is 8.0. So according to my definition or according to what we have already learned, in 8.0 this command is optional. You can perform it or not. First, let's run this command net control. So according to my definition, your traffic, if I'm performing telnet, it should not be work because my traffic is going through one interface to another, like from E0 by 0 to E0 by 1. So it's going through E0 by 0 to E0 by 1. So it should be netted. So let's perform the net. The command we already discussed, that static from inside to outside. The global IP, if I put question mark, so it is saying global IP address. So it is 101, 101 and the local IP address, the real IP address 12.1.1. So I am converting 12.1.1 into 101.1. So this is the syntax. So if the condition is satisfied of net control, I can easily access it. If I remove this command no net control, then also it's not going to affect it because this command is optional in 8.0 series. In 8.4 it is completely removed. So this is the first. So we can do one more thing. We can initiate the traffic. Let's run here debug IP ICMP. Let's see he's going to reply with which IP. So 23.1.2. So now my packet will be created here with the source IP of 12.1.1. So it is going to like this. Now ASA will going to convert it into 101.1. So let's check it. Yes, he's converting, and R2 is going to R2 is replying with 101. So by default, my ping is not going to work because ICMP is not inspected, as of you know. So we are going to create the access list. Any name ABC extended permit ICMP. It's really easy. Just go follow through this. The source is 23.1.1.2. So the host is, because my traffic is going to come through the outside. So this packet will come with the source IP of this and destination. So we are just going to cut and paste 23.1.2, and the destination is, our destination is this. So this packet is coming because this is echo reply, not echo. So he's replying with this packet. So access group ABC in interface outside. So my ping will work. Show XLA to check. This is my global IP and this is my local IP address. So now this is static. Let's learn about dynamic. So I will remove it. Clear configure static and clear configure access list. The next one is dynamic. Converting group or multiple IPs into some IP address. Suppose we have a 12.1.1, we have network like 12.1.1.0/24. I want to convert it into 101 to 1.5. I want to convert this network to 54 hosts into these 5. So I'm going to say NAT. My inside network is 12.1.1.0. The subnet mask is 255.255.255.0 and convert it into global outside 101.1.1 to 101.1.5, and I will use a reference number for both here. Suppose I am taking 15, just a reference number that you need to convert this IP address into which global. Suppose I am running 10 or 15 commands for different interfaces, so he's going to take this reference number. Okay, I need to look for the 15th number in the global command. Suppose there are 3 global command. Global, maybe another interface, that is DMZ 16 17.1.1.1 to 17.1.1.5. So he will only take this 15th number. So this is just a reference number. So let's perform it. So net inside question mark any reference number. See, you can read it here. This network ID will be referenced by the global command to associate a global pool with the local address. So 15, let's define the internal network and the global outside. So if I initiate show access, so one, always clear the accelerate table. I'm going to perform the net. So it's really good practice. So he's replying with the first IP address. So maybe you are not going to able to distinguish that this is the older one or the newer one. So I can change it. No issues. Clear. Configure global. I will remove the global command and I will use different tool. 1599.1 99.1 to 99 dot. I forgot the reference number, so the reference number is 50. Now, that's what I'm telling you. Always clear the accelerate table because the entries always remain in the accelerate table. Show accelerate. So he's taking that previously. So I will put clear accelerate. So it will remove all the previous entries because my session is already created. So it's going to taking that IP from that session. So I will clear accelerate, and now it's going to go through the pool. It will take the new IP address. So just clear the session, and you will see this IP address. If you want to open the access list, commit ICMP source. Who is replying? 23.1.2. Destination. It can be a pool, right? So I will put 99.99.99.00 and 255.255.255 dot access group ABC in interface outside. It can reply with any IP address, not 99.01. It can be 234. So that's why I take a subnet. I can think show excellent. So this is dynamic. The third one is pet. Pet. This means many to one. Here I will use a simple command nat inside. Suppose I have many IP address. I will take a subnet like this time I'm taking 70 number just for the reference. So 55 global outside, and if I put a command interface, so it will take the interface outside. So it's going to convert when my traffic is coming. It will convert the IP address from the internal to the interface of outside. So it will take 23.1.1. So let's check it. Let's remove the access list. Clear configure access list. Clear configure global and clear access list. So show running config. Show me the only the net. So we have one net. I don't want to convert it into pool. So I can convert it into interface that is outside. Sorry, the reference number is 15 and I will say interface. So outside interface address added to the pet pool. So it's going to convert it into the pet. So this time is replying with the destination. This is my IP. So when my packet is coming, is going to convert it into 23.1.1 and this 23.1.1 is going to here. So 23.1.2 is replying and this is coming like this. Now if I want to open the access list, I will use it access list XYZ permit ICMP post source is 23.1.2 the destination. We are going to always open the access list for the netted IP that is 23.1.1 access group XYZ in interface outside. My pin will work. Now we are going to use static pad, that is sometimes it is confusing. So static pad means port to port binding. So let's see how we are going to do it. Static means we are going to use the same command. Static in to out Here we are going to use some different things. Let's check it out. Here configure access list and clear configure net, clear configure global and clear the access table. All the previous entries will be cleared. Now I'm going to say static from inside to outside, and I can use this TCP. What is your global IP address? I'm going to say 101.1.1 as usual. And what is your port number? Which port number you want to use? So I will say, let's take 23 telnet port. What is your real IP? Real IP is 12.1.1. This is my real IP. This is my global IP. And what is your port number? So my real port number is 23. So to avoid this confusion, I'm going to use here 2323. If someone is hitting on this IP 101.1.1 my traffic will be redirected to 23.12.1.23 access list. Wait, I will show you ABC permit IP host. Anyone can come, but in this scenario 23.1.2 will become with a destination of access group ABC in interface outside. So if he is going to hit on 101.1.1 2323, it is redirecting to R1. So let's discuss this thing. I am saying TCP perform port to port binding of TCP, not UDP. My global IP is this. With the global port is 2323. My local IP is this with the local port of 23. So what I am saying, this is R1, this is ASA, this is R2. But I am saying if someone, it is always remain in the netting table. We already discussed this thing. That static is always remain in the, here I written it that the entry will remain in the net table. We're not going to flush it out. So if someone is going to hit on this IP 101.1.1.23.23, it will be redirected to 12.1.1.23. So when the person is going from lower to higher, we need access list. So I created an access list. That access list, anyone that is coming from this IP, like outside, this is my outside. If you want to go to this IP, allow him. So I allowed him. So he typed this command telnet 101.1.1.23.23, and this IP is going to redirect it to, this IP is redirected to 12.1.1.23. So this is static pet. The fifth one is identity net. Let me tell you why we are going to use the identity net. This is used when the net control is in running, when net control is running, and if you don't want to perform the net. So identity means converting the same IP into itself, converting the IP address to itself. Why? So that we can avoid net control. How we are going to do it? Small keyword net. Suppose it is inside, so I don't want to convert it into some another IP. I use here 0. That's how I'm going to do it. So let's do it. Here configure static and here configure access list. Yeah, access list. Suppose a net control command is running, so I'm not able to perform any ping. It is not going to work because it's ICMP. Even I'm not able to ping telnet. So I don't want to perform any net. Why should I convert to some different IP? So I will just say perform net because net control is running. So I need to perform the net. If I want to go from one interface to another, I will use 0 and say perform this. Convert 12.1.1.0 into himself. So this is called identity. I can perform this. I can perform talent. The password is wrong. I put Cisco OO. And if I put a ping also, it's going to reply with the same IP. And if I want to open the access list ABC permit ICMP host, there must be only one. Access group ABC in interface outside. I need to remove that command. Show access list. The acting is that. So the last type of net on ASA is, so let me note it down these things. Config show history. I will note it down and I will paste it. Okay, I will do it later. Then last one is, so let me clear configure access list, clear configure net. Now the last one is policy net. So I need to define a policy, if and then statement. R1 ESA R2. If and then statement. Suppose it has a loopback 1.1.1 and R2 has a loopback 2.2.2. I will define a policy that if my traffic is initiated by 1.1.1 and it wants to go to 2.2.2.2, then convert that IP address into this. And if my traffic is initiated from 1.1.1.1 and it wants to go to 23.1.1.2, then convert it into 99. Or maybe convert it into interface. So I want to create a policy. How am I going to create a policy? I'm going to use the concept of access list. Access list. So access list is saying that if my source is this and my destination is this, perform this net. So I will demonstrate you how we are going to do it. I'm going to use, first I will create a loopbacks, face loopback, so face loopback one. Uh, I don't want to waste my time for configuring static route, so I'm just running a routing protocol. Auto summary. My neighborship will be up, up, Membership is up. Okay, there must be a little problem because I'm deleting it. So show IP in brief. Here the loopback is 2.2.2. So I just change it. Loopback is 1.1.1. Here the loopback is two dot small w. Membership is up. So from here I can telnet 2.2.2. So from here I can perform telnet 2.2.2.2. Okay, q slash source loopback interface 1. Show IP int brief. My loopback is up. Show IP out. I have connectivity. Okay. So it's not performing because I'm running here a net control command. So no issues, no net control. I will remove it and now I can perform it. So with the experience that what you have done with your ASA, you need to be in your mind. So it access this policy ACL permit IP host 1.1.1 to host 2.2.2. That's it. Now I will go to net. That if my traffic is initiated from the inside with the list of policy ACL, then convert that into global 101.1. So if I'm telnetting normal, I will get the access. But let me show you ping 23.1.2. Now the destination is 12.1.1 means it's not converting this IP address into 101. It's not going to convert because this conversion will only occur if my host source is this and destination is this. So I will say ping 2.2.2. Now is converting, right? My access list entry is activated. It's not replying with the destination 1.1. It means is converting. So access list XYZ permit ICMP host source is this and the sorry not destination this out. My ping will working. So let's revise all the concept what we have studied. So this was my topology. Okay. The first we performed is static net. Static net. So the command is static, perform static. When my traffic is going from in to out, my global IP is what is my local IP? My global was 101.1.1, local is 12.1.1. We always open the access list for the netted IP. So access list, when my 12.1.1 is coming, it will be converted into 101. So when R2 is going to reply, he is going to reply to 101.1.1. So I will say access list ABC permit my ICMP traffic When I need to permit ICMP traffic, when my source is 123 1.1.2 and my destination is 101.1. Okay, the second one, dynamic. So in dynamic, we are going to convert multiple into sum. So multiple is going to take with the net in any reference number and the subnet. Even you can define this with the using of ACL and global out. When this 12.1.1 subnet from inside wants to go to outside, then only perform net. And what is the pool? Then we learn about PAT, that is converting multiple IP into a single IP. So I'm just taking a reference number 12.1.1.0 255 and I'm converting it to interface. So global out 15. You can use a single IP here, that is 101.1.1.1, or you can use some interface, not some. The interface that you mentioned here will be converted. Here outside is E0 by 1, the IP is 23.1.1, so it's going to convert it into fourth one, identity net. Converting the IP address into itself to avoid the converting it to itself to avoid that rule. That rule is nat control. So we just need to run a single command 0. This is the really important. That means many to one. Fifth one is static pad. Converting port. We are going to convert one port into another port by using the command static from inside to outside. Which port? TCP port. Okay, what is the global IP? This. What is the global port? This. So what is the real IP? This. And what is the real port? This. So convert, if someone is typing this IP address with this port number, redirect that traffic into this. The last one is policy. So I need to create a policy that suppose if and then statement. If and then. So I will create access list. If my traffic is sourced from this access list policy net, this is my access list name, permit ICMP, or I can say IP so that you can initiate TCP UDP also. Source is host is 1.1.1.1 and the destination is 2.2.2. Then use this policy. If this is my if statement, if my traffic is initiated from this to this, then statement will be this, that inside any reference number, then access list, the same name, policy net, then global outside anything like interface, pool, anything you want. Interface, you can define a pool here, you can define a IP. So anything that you want.